Hello everyone. Today we're gonna talk about flood fill and more specifically how flood fill is basically BFS in disguise. So here's the key idea you must remember. Well, if you think in terms of graph, you use BFS. But if you think in terms of a two-dimensional array or a grid, you use flood fill. They are the exactly same algorithm because both of them use a queue and guarantee shortest distance or full coverage. So instead of being scared of flood fill, just think, oh, this is just BFS on the grid. And once you see that, everything becomes much easier. All right, let's jump into our first example. Well, imagine you drop a seed at one point, which is over here. And so I throw in one, the number one in this case, and then this seed move to the four different directions. And so I throw in two over here, and those parts, those C's covers the four direction as well. Goes like this. So they spread their seed over and over. So this must be three, 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 and again it goes like this. It's gonna be four, 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 and four. And lastly, over here must be five. So I'm gonna show you how this works, how this basic flood fill example works in the Visual Studio. Well, first things first, I'm gonna write down the basic code first. We need a queue. With a node type because it contains the x, y value. There we go. Then we need the direction array because we're going through four different kinds of direction. There we go. And I'm going to divide into two different kinds of function. When it comes to initialization, we need to throw in the starting point, start y and start x, and we said that we're going to throw in one in this case, and I need the Bloom's two-dimensional array with 4x4 size. And on top of that, I need to throw the value of the start y and start x value into the queue. This is how we trigger the BFS. We need the now value from the queue. There we go. And then we're gonna go through four different kinds of direction. And this is how we get the next value for y value and x value. There we go. And then we are out of the range, which can cause the index underflow or index overflow. this is how we prevent that kind of situation from this code. And if the value is already filled with the different value, which is not 0, then it is already filled with a different value, so we need to skip it. Otherwise, I'm going to fill with the value with the current one plus 1. Yeah, here we go. And then we need to push the next value for y and x to keep this process going. So yeah, I think this is all about the coding part. Well, as you probably can tell, starting from this point, it spreads out to the 4 different kinds of direction. So let's compare with our expectation. 3, 2, 3, 4, 2, 1, 2, 3, 3, 2, 3, 4, 4, 3, 4, 5. Yeah, so this is how the flood fill works. There we go. Well, let's say you click one cell in the drawing app, which is this point, and all connected empty cells get filled with the color. Like this, whatever it is, it will fill with this color. And our goal is to count how many cells get filled. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Go 17. The final answer would be 17. Well, this problem can be solved with a double for loop easily, but the next problems cannot. So that's why we introduced flood fill here to build off of it. So there we go. Well, first things first, I'm gonna write down the basic code first. I need the queue. And I need a paint array with 5 by 6. So with the red color, I will fill it with 1. With the empty space, I'm gonna fill it with 0. There we go. And then in this case, I'm gonna use the visited array. I'm not gonna mark 1 directly into the paint array in this case. So I need a queue with the node type. Well, in this case as well, the node contains the coordinate value, which is y and x only. And for the initialization, and well, like I said before, the starting point is 1 and 1. Start y, start x. And I'm gonna mark visited array, start y, and start x as visited. And I'm gonna push to the queue to trigger the BFS. There we go. This is all about the initialization when it comes to flood fill. Well, to count the empty space, I need the count value, which is initialized with 0 in this case. And we need to count from the starting point. So I'm going to increment this value from here. And all we have to do is just write down the code for the BFS. We need the direction array as well. With the 4 different kinds of direction. So this is how we express the next coordinates. And if we are out of the range, which causes the index underflow or overflow, we have to throw in this code to prevent that kind of situation. And if paint is 1, which is red color already, we need to skip it. And if the empty space is already filled with the color, I'm gonna skip this process as well. Otherwise, I'm gonna mark it as colored. And so after that, I'm gonna push the next coordinate. There we go. And then we have to increment this value. There we go. It must be 17. Let's move on to our next example, which is maze example. So you're inside a maze. You want to know the minimum number of steps to reach the exit, which is over here. So if I count the minimum pass, 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we have to contain the level to calculate the minimum pass. And so we need the visited array to guarantee the shortest pass. And then we have to contain not only the coordinates, but also the level value. There we go. Well, first things first, I'm going to write down the basic code first. So we need the queue. Well, I'm going to name it maze with 5 by 5, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 0, 0, 0, 1, and 1, 0, 1, 0, 0. And our target y and x is 4, which is this exit coordinate. And we need the visited array, same as the maze size, and I need the structure, which contains the level as well. We need a queue with the node type, and I need the direct array as well. There we go. And then need to initialize for the BFS. So our starting point is 0 and 0, but I'm gonna make a parameter. There we go. And then I throw in level, which is 0, and I'm gonna mark visited array as well. And I'm gonna make the BFS function separately. It's gonna be 0 and 0. Let's write down the basic BFS code first. Well, if we found the target y and target x at the same time, which means that we arrive at the destination, I'm gonna return now level right away. We're gonna go through 4 times for the direction. And we need to care about the boundary condition. And if maze value is 1, which is the black one, which is blocked already, I'm gonna skip it. And if visited array is already marked, I'm gonna skip it as well. Otherwise, I'm gonna mark it as visited. And I need to push the next coordinate value to trigger the next process. And yeah, one more thing, we need to increment the level value as well. So yeah, I think this is all about the BFS code. If I execute this file, 8. Well, just so you know, we can check the next value right away over here. If next y is target y and the next x value is target x, which means that we already found the destination. It works exactly the same, but this code is slightly faster than this one, so this is your choice. There we go. Let's move on to our last example for today. So imagine a dry forest after a long drought. Some areas contain dry bushes, and some areas are completely fireproof, which is the blue one, which can be rocks or rivers. And fire can only start in vulnerable zones. So our goal is simple. How long does it take for the fire to spread as far as possible? Let's say fire starts from here and here. So the time would be 0 at first, but if the fire spread like this with the 4 up, down, right, left, direction, it would take 2, 2, and it must be 3, 3, 3, and 3, and those would be 4, 5, 6, 7. So it takes 7 minutes to get entirely burnt. Well, I'm gonna write down the basic code first. I need a queue. Well, I need the structure, which contains the coordinate value and time. Well, I need the initialization first. And I need the queue with the node type. Then there's the forest with 4 by 7, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, and 0, 0, 0, 1, 0, 0, 1, no 0. And I need a direction array as well, with the 4 different kinds of direction. There we go. And I need the burn array, which plays the same role as visited. Yeah. I need to push some value for the starting point. In this example, there's the 2 starting points. There we go. And I have to mark at the burnt array. 0, 0 is already burned. And 3 and 5 is already burned. This is all about the initialization. I need the now value, and we're gonna go through 4 different kinds of options for our direction. And this is how we get the next coordinate. And we need to care about the boundary condition. It's 4, 7. I'm gonna skip. And if we meet the fireproof zone, we're gonna continue as well. And if it is already burned, I'm gonna skip that. Otherwise, it is a burnable zone. And I'm gonna push the next coordinate value. And this is all about the code, and to get the last time value, we need to get that value from the last push code, because the value that we push for the last time is the maximum time to get the entire forest burned. So if we print out the last time value, it's gonna be 7. 7. There we go. And then you can do this. Um, you can do the same code like this over here. So it's gonna be now time. So if I execute this file as well, 7. So you can throw in the code over here or over here. This is up to you. So, well, this is all about the today's video, and I hope you find it very useful through this video. Well, thanks for watching, and see you on my next video. Bye, guys.